Hello learners, welcome to session 3 of unit 4, that is upper bounds of subsets of real numbers. So in previous section we look at real number systems. So in this session you will learn more about upper bounds, and in the next session we also discuss lower bounds. Great. By the end of this session, you should be able to explain what is meant by a bounded set, describe and give examples of bounded set. You should be able to describe upper bounds, explain the terms primum, and determine the primum of a given set. So this is and. Okay. Definition. So we said in the previous lessons that a set of numbers is bounded if there is a number m such that the size of every element in the set is no more than that m, and unbounded if there is no such number or there's no such recession. So such number is called a bounded or bounded on the set. So we are looking at this definition. Let's be an empty subset of the real numbers R. We say that the set is bounded above if there is a real number m such that x is less than or equal to m for all x in S. The real number m is called the upper bound of the set S. We say the set is bounded below if there is a real number m such that m is greater than or equal to m for all x in S. This real number m is called a lower bound of the set S. So that's the condition for lower bound. X is less than or greater than or equal to m, and once it's less than or equal to m for all x in X, then we say that that is upper bound. So if set S is both bounded above and bounded below, then we say the set is bounded. If the set is not bounded above or below, then we say the set is unbounded. So once the only one condition fails, we say it's unbounded because it can go in other direction. Great. Okay, let's look at example 12. Let S be a set such that x less than 1 and x a member of array. We want to show if S is bounded above, then we find that's an upper bound. So clearly you can see from the set that the set is bounded above by 1, because for all x in S we have x less than 1. All elements in the set are less than 1. Hence 1 is an upper bound of x. So any real number greater than 1 can also be an upper bound. So we look at the least upper bounds, then we know the difference between them. So the upper bounds are 1, 2,000, 3,000, or all those numbers are upper bounds. So the answer to this one is actually yes. It's yes. And the upper bounds are many upper bounds we have. Okay, so B. Is S bounded below if E has determined a lower bound? So you can see that the set is not actually bounded below because there's no real number m such that x is a member of S for all x greater than or equal to m, and that is actually the condition, and there's no a lower bound actually, because the x is less than 1 and we have more numbers less than 1, no, less than 1. So we can say that the set is not bounded below. Set is not bounded below. Okay, so is the set bounded or unbounded? So the final answer is what? 1 is not bounded below, so the set is not bounded, it's rather unbounded. Though it is bounded above, but it's not bounded below. So we can say that the set is unbounded. It will grow to one direction, it will grow and grow and grow. There will be no limits. There will be no limits. Okay, and then bounded sets are very important. So if you know, as a human being, you should always know your bound. You should always know your range, so that you don't eat into somebody's range. So that is very, very important as far as real life is concerned. Okay, let's look at list upper bound. LUB, list upper bound. So let S be an empty subset of which is bounded above. Then a real number U is the least upper bound. Another name is the primum. We've already looked at that. So if the U is an upper bound of the set S and it doesn't end there, once you identify that it's an upper bound, there might be more upper bounds. So the next condition is that the U prime is any other upper bound of the set S, then U is less than or equals to the U prime. Then we say that it is the primum or the least upper bound. So the primum is the real number which is the least upper bound of a set and is denoted by the sup. Sup S. It's not the soup you use to eat. No. So we pronounce it as soup. Soup. The same spelling. Soup. S-O-U-P. Soup S. Soup S. So in the above definition, the soup S is actually the U. There must be a number of them. I want the least one. Okay. Example. Let's see this example. Let A equals to x such that x less than 2. We want to determine the real number sup A. So sup A is the least upper bound. So you can see that since 2 is an upper bound of A and is the smallest upper bound A, and that is 2 is not a member of the set A. So the primum is not necessarily a member of the set. It's not necessarily the set. So you need all numbers that are less than 2. You can see 1, 0, -1 in that order. So the sup here is actually 2. So the solution is sup. Here is 2. Sup of A equals to 2. But you may have more upper bounds, 2, 3, 5, 100, 10,000, 1 million, 1 billion. But the least one is 2. And that is sup. That is sup. It doesn't mean that the sup should always be part of the set. It may not. Good. So we are looking at the next example. Let B equals cos x, and x is a real number. You want to determine the real number sup of B. The sup of B. Okay, so you can note that the cos is the values of cosine of angles or real numbers, and I think you agree that. And what are the range of cos? The cos ranges are -1 is less than 2, let's say cos x, and at the same time less than equals to 1. So this is the range. So there are infinite number of upper bounds of the set B, because the least one is 1, so you can have 2, 3, 4, 5, 20,000, 30,000, and the rest. So therefore, since the least one is what? 1, so the sup of B equals to 1, because that's the least and the 1 is included. Okay, so now you see it clear that how to find the sup. The upper bounds. There are many upper bounds here. 1, 3, 5, all positive numbers, but the least one is 1, and that becomes the primum of the set B. Good. Let's see example 4. Example 14. So you have, let's see, equals 1 on n, and n is all members, that is natural numbers. We want to determine the sup of C. So let's see the set of the natural number that correspond to 1 on n. So that means that natural numbers start from 1. I put 1 inside, I get 1. Then I put 2 inside, 3, 4, 5, 6. So you can see that 1. Then I put 2 inside, I get half. I put 3 inside, 1/3, 1/4, etc. A lot. And that is up to 1 on n, and that is same as C. So that's actually the values of C. So the set C is bounded above because for all n there is 1 on n is less than or equals to 1. So in this instance, what is sup? you can say that the soup of C equals to 1. The soup of C equals to 1. It's not 7. Including that is 1. Okay, so all these are soups, 1/2, 1/2, 1/3, and the rest, but the least one is 1. So the soup is 1. Okay, then next example. So example 15, let D equals 1 on 1 plus n squared. As usual, n is a member of n, the natural numbers. You want to determine the soup of D. So the same thing, you list the elements of D. You put, let me clear this. So D equals 2, you put natural numbers, put 1 inside, get 1 on 1, that is 1. Put 2 inside, what do I get? Oh, when I put 1 inside, you don't get 1, get 1 on 2. Good. Then I put 2 inside, get 1 on 5, and then 1 on 10, and that's that 1 on 10 up to 1 on 1 plus n squared. So what can we see about this? So you can see that the set D is bounded above, that is the LUB is actually equals to half. The LUB is actually equals to half. Therefore, the soup of D equals half. Okay, so that is the lowest upper bound for this sample 15. Thank you. Let's E equals 1 minus 1 on n, and n is a member of natural numbers. We want to determine the soup of E. So how do we then determine the soup of E? First, we list down the elements. That's E equals to, we put 1 inside, get 1 minus 1, that is 0. I put 2 inside, 1 minus half, I get half. I put 3 inside, I get 2 and 3 in that order. Once you're able to establish this, then you can see that the set E is bounded above, because for all n in E, so there's a least upper bound of E, and that least upper bound of E is the soup. So the soup of E equals to 1. That is the least upper bound equals 1. This one is upper bound. Let me clean this. Okay, the least upper bound equals to 1. So that's very interesting.